Okay, good morning, guys. Welcome to the lesson. Okay, what was the last unit? It's powers and squares and cubes. About we had learned about powers and cubes, if you remember. And I want to show you some examples with that last unit, about last unit to remember. So, write each expression as a power or fraction. So, first of all, in option A, and here, I'm writing here. Okay, can you see my letters? 8 power of 3 or 8 cube and times 8 power of 4. So what was the rule? If our base are same, we can write that only one time of base or 8. Okay, so it's 8, and as we have times, what was the rule? The powers are adding. 3 plus 4 is equal to 8 power of 7. Okay, this is so big number, and that's why you can calculate with your calculator, and it means 8 times 8 times 8 times blah 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 8. How many times 8? There is we have 7 times. Okay, so and option B also same way you can follow, as we have secret one, and the base are same, and between bases we have multiplication. That's what the powers are adding. 2 plus 1 is 3, so 5 power of 3 is 125. Okay, and also see the same. I want to show D. Okay, 9 power of 2 divided by 9 power of 3, or 9 cube. What does it mean, division or divided by? It means in fractional form you can write it is equal to 9 power of 2 or 9 squared divided by 9 cube. Okay, and the operation is not finished. So in other words, we can write it 9 power of 2 minus, because there's we have divided by. In a divide by, you can write it subtraction. You can use the subtraction. Okay, it's 3 because the bases are the same. That's why I'm here also. I have wrote only one time of base. Or in this case, in a 9, the power of minus 1. But we need the positive numbers. So what can we do? Yes, exactly. There's we have secret one. Just a numerator goes to denominator, and the denominator goes to numerator. That's why this place us changed, and the power of 1, or 1 over 9. Okay, and here also the same way you can follow. The powers are bases are same. 12 power of 2 minus, because there is we have divided by 4. 2 minus 4 is 12 power of minus 2. As we have, if the positive, it was the positive, the answer was 144. But in a negative form, you can write in a fractional form 1 over 12 power of square 2, or 12 square is equal to 1 over 144. Okay, and the answer is 144, exactly 1 over 144. And find the value of n each part. So like expression or equation, there we have the base are same, and the question is about powers and exponents. So how can we find the n? There's okay, what was the rule? If there's we have the base are same, we can write only one time of the base, and 2 plus, because of as we have into the middle multiplication. That's why 2 plus n is equal to 10 power of 4. Okay, so if you look there carefully, the base are same. You can directly cancel it. Okay, and 2 plus n is equal to 4, and from here n is equal to 4 minus 2 and plus 2. So and from here you can put the place of n just 2. Okay, and I want to show this one. about divisible or divided by. Also here we have the same basis, 10 power of 2 or 10 square and minus n. Okay, because of there we have divided by n is equal to 10. And also exactly here, if there is no any number, it means n 1 just. So you have already canceled that basis because they are same and just powers are the same to each other. 2 minus n is equal to plus 1. And from here you can find of n. Okay, so minus n is equal to 1 minus, because of that we have plus, and that goes to other side or right side, and the sign is automatically changed. And minus n is equal to minus 1. From here we can divide by minus 1 because of we need just n plus n. That's why minus divided by minus plus, and n is equal to minus divided by minus is plus. So n is plus 1. Okay. And today we have the chapter number is 2, a new subject, new unit, and sequence and functions. What does mean sequences? You can check, please check it. And first of all, make sure you learn and understand these keywords, especially these 6-7 words. Okay. And the sequences, what does mean sequence? A plural form of sequences. And the functions, I mean the functions are the same your language. So linear sequence and non-linear sequence, term-to-term rule, position-to-term rule, arithmetic sequences, nth term, and inverse functions. And here I'm going to read the some rules, definitions. Okay, just all children learn to count, and they learn this sequence of numbers. For example, this one is the natural number, and 1 from 1, then you will count from 1 to the second term, or the second number must be 2, 3, 4, 5, 6, and blah blah to plus infinity to forever. And you can use this sequence to make a new sequence by coloring numbers in equal steps. Here are 3 examples. And first of all, 1, 3, 5. If you look, there we have odd numbers. And this gives the odd numbers. The others, 2, 4, 6 are evens. And 1, 2, 3, 4, 5. And between two numbers or two digits, and between 2 and 5, we have two numbers. And here also we have two numbers. If you look, the different are the same. It's increasing by the same amount. And this gives the sequence 2, blah, blah, 5, blah, blah, 8. And if you look, the difference is plus 3. And here also plus 3, plus 3. And between 20 and 23, the difference is plus 3. Okay. And 1, 2, 3, 4, 5, 6, 7, as we have 4 terms. And also we have 4 and 4, blah, blah, blah. This gives the sequence also 2, 7. Between these two terms, we have plus 5, plus 5, plus 5, plus 5. Okay. Can you find the 10th term of each sequence? Exactly. Yes, we can find it. It's not difficult. And you should know how to use the formula for the nth term of the sequence. Here are the nth term of the 3rd sequence. They're not in the correct order. Okay. From here, we'll continue. Generating sequence. In a linear sequence, what's a linear sequence? It's our new word, new keyword. It's a linear sequence. Nth terms increase, please look carefully, increase or decrease. It's not important, increase or decrease, but the important is same, but the same amount each time. For example, 1, 2, 3, 4, it's increasing by 1, the same amount, okay? Or it's decreasing, -1, -2, -3, -4, it's decreasing, -1. And amounts are the same. It's a linear sequence. In a non-linear sequence, the terms increase or decrease, also increase or decrease, by different amounts each time. Different amounts, for example, 2 and 8 and 10 and 13. The difference between are difference are not same. Okay, it's increasing, but the difference are not same. Here is a non-linear sequence of numbers. For example, 3, 6. Between 3 and 6, there's we have 3. Okay, 3. And between 6 and 11, there's we have 5 and 7 and 9. Just all difference are the odd numbers, and the increasing not same amount. 3 is less than 5, also less than 7. Okay, so look at the differences between each of the terms. Okay, can you see that the difference between the terms are not same? The term-to-term rule is at 3, at 5, at 7, at 9 is a rule of term-to-term rule. And the next rule is the position-to-term rule for this sequence is term is equal to, for example, term means values of each numbers or each positions. The first number is 3, and the second number is 6, and the fourth number or first value of this sequence is 18. Okay, and for this how can I say sequence, the formula is term or 3 as equal to position number. Is position of 3 is 1, is first position, 1 square in the brackets, 1 square and plus 2 in a formula. Okay, let me check it. Is it correct? 3 is equal to 1 square is 1 plus 2. Yes, exactly. This one is 3. 3 is equal to 3 is correct. And position number, for example, term is 27. 27 is equal to a position number. Which position of 27 is 5? 5 square plus, what was the formula? Plus 2. And 25 plus 2 is 27. Is also correct. Yes, exactly correct. And I want to know, for example, what is the, how can I say, nth term, or how can I say, 100th term. And I don't know 100th term. There's we have position number is 5 and it's finished. And I need x. We need x is equal to position number is 100. And in the formula, square plus 2. And x is equal to 100 square is 10,000 plus 2, 10,000, 2. So the x was term. The hundredths position number, hundredths term is 10,002. Okay, and the others also the same mean. You can stop the video and please listen again. If you don't understand, you can ask us also. So for example, the sixth term is equal to 6 square plus 2. 6 square is 36 plus 2 is 38. So after this number, or the sixth position is 38. Okay, and let me check it. The differences of these terms between 3 and 6, there you have 3, a 5, and a 7, and then 9. After that must be 11. We have to write the 11. So that's why 27 plus 11 is equal to 38. Also correctly. Okay. And worked example. Are these sequence linear or non-linear? Let me check it. But first of all, what was the linear sequence? Is increasing or decreasing by the same amount? Okay, it's no problem decreasing or increasing. Just we need the same amounts. It's increasing or decreasing. 2 and minus 1. Between 2 and minus 1, there is you have minus 3. And the next term is minus 4. The same amount is decreasing. Okay, so it's a linear equation. Linear sequences. And linear or non-linear. Okay, the first one is 6 and 4. Between 6 and 4, there's we have minus 2. And between 4 and 2, just we have also minus 2. And between 0 and minus 2, we have also the difference is minus 2. That's why it's decreasing exactly, but the same amount is increasing. That's why it's a linear sequence. Okay, so the sequence is decreasing by the same amount, minus 2. Each time the sequence is decreasing by the different amount. Sorry, it's the for second one. It's first one is exactly the sequence is linear. Okay, and the second sequence is 8. First term is 8, and the second term is 5. And in between 8 and 5, there's we have minus 3. And between 5 and plus 1 is minus 4. Okay, it's enough. So it's not linear, non-linear. Let me check also the explanation of this sequence, this question. The sequence is decreasing by the different amount, 3, 4, 5, 6. In this case, the sequence is non-linear. And the question B, the first term of a non-linear sequence is 4. It's non-linear, and the first term is 4. Okay, the position number is 1. It's because of the first term means the position number is 1. Okay, for the term-to-term rule is multiply by 2. By 2, multiply by 2. The first term is 4. The second term must multiply by 2 is 8 exactly. And 8 times 2 is just 16. And as you see here, the difference are not same. Between 4 and 8, there's we have plus 4. And between 8 and 16, there's we have plus 8. That's why it's non-linear. Okay. Write down the first term, which is 4. Then use the term-to-term rule to work out the next 3 terms. Second term is 4 times 2 is 8. Third term is 16. And fourth term is 32. Okay, sorry. And the first 4 terms are, okay, question is here, sorry. The position to term rule of a nonlinear sequence is term is equal to is x, position number. So that's why first we need the work out the first 4 terms of sequence. Position number means that we have position number. The first position number is 1 exactly. It's just natural numbers from 1 to infinity. Okay, so we need just 4 terms, 4 first terms. That's why the position number is starting with 1. And a formula already given terms is x. We need the x is equal to 2 times in a formula. Position number is 1, as we have square. Yes, 1 square is 1. 2 times 1 is 2. So first term is 2. Okay, and the second term, what about second term? Second term means position number must be 2. And x is equal to its second term, or how can I say, how can I write it? Can I write here? Okay, second term is equal to 2 times. Position number must be 2 square. And second term is equal to 2 square is 4. 4 times 2 is 8. And as you see here also, second term is 8. And in between, difference of this sequence is not same. It's increasing, but the differences are not same. That's why this sequence is a non-linear sequence. Okay. And here some examples about our unit. What's that? Okay. Write down whether each sequence is linear or non-linear. Let me check it. If the differences are the same, increasing or decreasing, it's linear sequence. If it's decreasing or increasing by the different amounts, is not or non-linear sequence. Let me check with A. 11, the first term is 11 and the second term is 15. Between 11 and 15 we have plus 4, and the second plus 4, plus 4, plus 4, and plus 4 is 31. Okay, so this one is linear. just L. Okay, and B 10, 10, 10, 10, also L, and D 20, 18, between 20 and 18 plus, sorry, minus 2, minus 3, minus 4, minus 5 is not or non-linear. Okay, and others for you. And write down the first four terms of each sequence. First term is 8. Okay, term to term rule is subtract 5. The first term is 8 and subtract minus 5, and the second term must be plus 3. And minus 5 is minus 2. Minus 5 is minus 7. Minus 5 is minus 12. And we need first four terms. Okay, the first term is 8, 3, minus 2, minus 7. Just it's not, but it doesn't matter. And the first term is 1 over 2 is equal to, that means 5 over 2 or 2.5. Okay, term to term rule is add 1. Add 1. 2.5 plus 1 is 3.5 plus 1 is 4.5, and the fifth or fourth term is 5.5. It's first term, and a second, third, and fourth. And yes, it's finished. And the first term is 4. Term to term adds 1, or yes, and blah blah blah. I can't see this explanation. I'm so sorry. In my screen, there's some presses. Okay, now. So first term is 4. Add 2, add 3. Add 1, add 2, add 3. First term is 4. Term to term rule is 1. Plus 1 is 5. And plus 2 is 7. Plus 3 is 10. And it's also non-linear because of the difference are not same. Plus 1, plus 2, and plus 3. So, and third exercise, Zalika is trying to solve this problem. Work out the answer to the problem. Explain the methods you used to solve the problem. The tenth term of the linear sequence is 18. It's tenth term. Tenth term is 18. Okay. It's a linear equation. Sorry, a linear sequence. It means the difference are the same, increasing or decreasing. The term to term rule is subtract 4. What does it mean subtract 4? Minus 4. And work out the fourth term of the sequence. We need fourth term. Okay, so it's a 10th term. How can we find the first term? Just it's 10ths and a 9th and 8ths, 7ths and 6ths, 5ths, 5ths and 4ths. And minus 4 is plus 14 plus 10 and 6, 2, 1, 2, 3, 4, 5, and minus 2, minus 6. Okay, so the first term is minus 6 because of its linear sequence. Thank you. Use the position to term the first four terms of each sequence. And if term is equal to position number, it's our formula. Position to term. Please read that carefully. The how can I say definitions or words. Okay, and term is equal to position number plus 5. Term means x. Position number is first. If we need the first term, it means 1 and plus 5. So its first term is 6. And we can write here position number and terms 1, 2, 3, 4, 5. It's first number, first position, second, third, fourth, and fifth. And what was the first term? Is 6. And first 4 terms we need. And the second term, second position number, we can put the position place of position number just 2. 2 plus 5 is 7. 3 plus 5 is 8. So different the same, plus 1, increasing plus 1. It's linear sequence, okay? And to solve C and others for you, please send me your solutions, some friends as from your class. No, I cannot see from ninth grade. They have sent the answers, and I gave them class. And term is x is equal to position number is 1. For example, I want to first term and plus 4. The first term means 1 plus 4 is 5. Okay, so first term is 5 for this, how can I say, formula. Okay, and a second term means 2 square. X2 is x1. X1 is x2 means the first term and the second term, okay, place. And a second 2 square plus 4 is 4 plus 4 is 8. And the second term is 8. And the third term is 3 square, 9 plus 4 is 13. And the fourth square is 16 plus 4 is 20. And what's about the difference? Plus 3, plus 5, plus 7, it's non-linear sequence. And others for you. Thank you for your attention. See you in the next lesson, guys.